What's up everybody, welcome back to Head Ass Garage and welcome to a new video. In today's video we're going to be going over valve lash on my Honda S2000 and doing a compression test as well. So let's get straight into it. I've already gone ahead and gotten the valve cover off, however you will need to disconnect the intake and exhaust side cam positioning sensor from off of the valve cover in order to get it off. I'd also recommend taking off your VTEC solenoid and what I believe is a NOx sensor just below it so that you can get the wiring harness out of the way to then get your valve cover off. This will need to come off of its tab here in order to get the valve cover off. However, it's not hard to get this off, and once that's out of the way, the valve cover should come off pretty easily. Now that I've gotten the valve cover off the head, I can go ahead and service the valve cover gasket. If you're doing a valve lash yourself, I'd highly recommend getting a new gasket and new spark plug seals. And the reason for that is this, I'm assuming, is an old one, and it's behaving almost like plastic. There's no elasticity to it when there should be. So we'll get this old one out with this new gasket here. It's much spongier, feels more soft and like a rubber, whereas this one is incredibly hard. I can't squeeze that at all, or at least not much. It takes quite a lot of force to do so, whereas with this one, you can see it's quite easy to squish. So if your valve cover gasket is hardened by any chance, I'd highly recommend getting a new one if you aren't just going to regardless. But go ahead and get that switched over to this, and I'll update you when it's done. So we've got the new valve cover gasket in, and one thing that I notice is that this gasket is sitting up from this lip here just a little more. There's a slight bit more height to it than there was on the old one, and it just feels a lot better. It's gonna allow us to get that seal that we need once it goes back on. Another thing, I have the old seals there, and if you notice, the hole is actually quite a bit larger on the old one than it is on these ones. There was some oil inside of the spark plug tubes when I was working on it, so the previous owner more than likely got a set of aftermarket or just cheap seals, and that's why it got as hard as it did and why there was oil being let by these seals. However, we got the correct ones in there now. They feel much better, much more spongy. This gasket feels much better, much more spongy. So hopefully the motor will be a hell of a lot more sealed and we can keep going. The next thing that I'm gonna do is remove the 4 spark plugs so that I can easily turn the motor over to top dead center. And if you aren't aware, you remove the spark plugs so that the motor is no longer making compression, and it'll be a lot easier to turn over and get to top dead center. Also, if you're unfamiliar with Honda motors, this valve train might look a little different because you have 3 cam lobes. And the reason for that is these are your regular cam lobes, so regular exhaust side cam lobes, and then your VTEC exhaust side cam lobe. Same thing mirrored for the intake side, so regular intake cam lobes and then your VTEC cam lobe there. So I've gotten the spark plugs out, and as you can see, there is an alarming amount of oil on them. I think alarming might be an understatement. However, that goes back to these valve seals that were used, which were just too large. This center diameter is far too big and there's no sponginess to it, so it wasn't doing its job of sealing, and we had a pretty alarming amount of oil on top of the spark plugs, and the actual spark plugs themselves look pretty damn bad, if I'm honest. So we'll get the new one switched over, new seals, and that should hopefully fix our problem. However, let this be a lesson: always buy the OEM and correct parts. check fitment beforehand, and you won't have problems like this. Thank you to the previous owner. All right, so now that I've gotten these spark plugs out, I should be able to rotate this over to top dead center. Couple of things that you want to keep in mind before you start your valve lash. Be sure to let the motor cool down to room temperature or just below 100 degrees Fahrenheit. The reason for that is so that you can get the correct clearance between the metal. As it heats up, it'll expand, so it's important to get it down to room temperature so that your measurements are accurate. Another thing to keep in mind, there are markings that I will show you once the motor is at top dead center that indicate that cylinder 1 is at top dead center. We will then go through the rest of the car in its firing order, which is 1, 3, 4, 2. So we will adjust the valves in that order, and I'll take you guys along step by step. When turning the motor over to top dead center, the bolt down there is a 19mm bolt. Go ahead and have your wrench on loosen so that you are turning the motor clockwise. All right, so we've got it at top dead center now. And the way to tell is you'll see that timing mark there. That timing mark there, they should be facing each other, and your exhaust side cam lobe should be pointing at 11 o'clock, this at 2 o'clock. So you can see we've got it at top dead center, and we can go ahead and service the valve lash now. Honda recommends that you use a jam nut tool in order to do your valve adjustment. However, after ordering one and them saying that it was delivered and it's still not here, I'm gonna go ahead and give it a try without a jam nut tool. And if you're seeing this clip, that means that you can do it without it. For the exhaust side, you're going to want to find a feeler gauge between 0.25 and 0.29 millimeters. I've got my 0.254 to err on the side with less clearance and get the clearances just a little bit tighter. So now it's time to do our adjustments. Go ahead and crack that nut just right there, and then adjust the screw in the middle, and it should change the clearance. And just measure it until you have a slight drag between the screw itself and the feeler gauge. Shouldn't be too hard to go in, and it shouldn't be too hard to take it out. You shouldn't get too much resistance, but you do want just a little bit of drag going in. So I've got this one where I think it needs to be. And as you can see, that slides in. There's just a little bit of drag, and it slides out. So that should be what you're looking for. I'm gonna go ahead and tighten down that lock nut now. We'll see if it works without the jam nut tool. Hopefully that screw right there doesn't move at all, and if it does, adjustments back and forth until you get it where you want it. Drag going in. For intake side, the recommended clearance is between 0.21 and 0.25. So I've split the gap at just about 0.23. Go ahead and repeat the process that we did on the exhaust side to the intake side, and then we'll move on to the next cylinder. I've gone ahead and done the valve lash on the first cylinder. Just a reminder, the factory clearance recommendations for the exhaust side is 0.25 to 0.29 millimeters. On this side, it will be 0.21 to 0.25 millimeters. Now it's time for me to rotate the motor 180 degrees, and then we can service cylinder number 3, then 4, then 2. So I've gone ahead and rotated the motor over 180 degrees. Something to keep in mind, or something to help you know when it's at 180 degrees, is the crank will rotate twice for every one rotation of the cam. What that means is for 180 degrees, where the marks were here, they should be 90 degrees that way, 90 degrees that way. So sitting at the top of the cam sprocket here and at the bottom of the cam sprocket on the intake side. Now it's time to service cylinder number 3. I went ahead and put these 2 extensions in there just to be sure that is at top dead center. Another way to tell, similar to cylinder number 1 when it's at top dead center, this exhaust side cam lobe on cylinder number 3 should be pointed to 11 o'clock and the intake side to 2 o'clock, just as it is there. Cylinder number 3 is done, so now it's time to repeat the process. Just rotate the motor 180 degrees. Then we can service cylinder number 4. Another indicator will be 90 degrees more rotation on each of the camshaft sprockets, and again, the cam should be at 11 and 2. As you can see, cylinder number 4 is at 11 and 2, and the cam sprockets are again 90 degrees off. Okay, so I just finished up the valve lash. As you can see, that last one that I had to do, cylinder number 2, is pointed at 11 and 2, and another 90 degrees of rotation on here. Alright, so just for reference, you can see the seal that I replaced just right there, and it's actually, you can see, making a connection with the rim of the spark plug / coil pack tube. Whereas before, they were pushed down the tube and this was all empty space there. That is not what you want. You want it to be like this, where it's fully sealed. So hopefully no more oil should be getting in where the spark plugs were. Before you get started on your compression testing, be sure to pull the fuel pump fuse so that your fuel pump does not turn over when you try turning the car over. So we've gone ahead and done the compression test on the first cylinder. We went and picked up this Loan & Tool compression tester from AutoZone. A lot of auto parts stores offer several tools that you can loan out, so we went ahead and got this. The first cylinder measured 210 compression, which is beautiful, exactly what we wanted. So we'll go ahead and get this next one started.
Here's cylinder number 3. 210. Here's cylinder number 4. Yep, so that's 210 again, so all 4 making good compression.
Heck yeah. All right, so we got the new spark plugs in. We'll have the ignition coils to follow. Right now I'm reattaching the VTEC solenoid. I'll be attaching that knock sensor back to its spot right there. So I got both of those bolted back up. I have one cam position sensor there bolted back up, the other there. As far as I know, the last thing to do is ignition coils, and I have a set of all new Denso. These are the OEM replacement ignition coils. Got a brand new set of 4 that I'm gonna go ahead and throw in. I'm gonna go ahead and throw the fuel pump fuse back in, and then this thing should be ready to fire, and hopefully sounding a hell of a lot healthier than it was. All right, so it's now the next day. We've already done the valve lash and compression test, and I'm very happy to say that the motor is running so much better than it was. With the new motor mounts as well, it is a much smoother ride, and altogether the mods that we did, returning it back to the way it was supposed to be from factory, has made the car 10 times more drivable and much more fun to experience. More content on this thing coming. I'm very happy with what we've done to it. We'll have content on her coming soon as well. If you can't tell, Marcus is grinding away as we speak, so this beauty will be coming back with lots of mods and lots of updates. Yes, sir. So that was how to do a valve lash and compression test on your S2000. This was Head Ass Garage. We thank you guys for watching. Please like and subscribe, leave a comment. I'm Josh.
I'm Marcus.
We'll see you guys in the next one.
Peace.